In earlier videos, we have been looking at how we can use Activeloop and Deep Lake for dataset versioning and dataset exploration. And we covered the basic of how to do it in those two videos. In this video, we're going to look at how we can use Activeloop to understand and evaluate our detector that we have trained. And we will also see how we can use it to find new images to annotate. And especially we're going to use it together with Manot or manot.ai, which is an intelligent tool for selecting what kind of images you should annotate next to make the largest difference on the detector. So basically when we select new images or randomly sample images, there might be a lot of images where it doesn't happen much interesting in, or images which are very similar to the images that we already have in our data set. And then it is very valuable to have some kind of anomaly detection tool and tool that can find interesting things happening in the images. And that's exactly what Manot is doing for us. So it will save us a lot of time, both in selecting images, but also making the whole process more efficient. So we don't need to spend as much time annotating images, since each image we annotate is much more worth to the results. But for now, let's start by looking at the evaluation of the images. So what I have here is a data set which contains my images, and it contains the annotated bounding boxes, which are the box that is not dashed, but the other one, the solid line box. And we have the dashed box, which is the actual prediction from a model. So after annotating all images and training my detector using the TensorFlow object detection API, I checked out a new branch in Activeloop or in Deep Lake and created new tensors in that branch to contain the predicted bounding boxes. So I have uploaded the result of the predicted bounding boxes. I have uploaded labels, the predicted labels, and the score from the prediction, how confident it is. And I have also run an evaluation script which calculates the intersection of a union between the ground truth bounding box and the predicted bounding box. So that is the measures we see here. This is the mean IOU of all the bounding boxes in the images. This is the minimum and this is the maximum. In this case, we just have one bounding box, so they are the same. And this is the number of true positive, the number of false positives, and number of false negatives. So in this image, we can see that it's correctly classified, which is not that surprising considering that this is the training data. So let's select only images which contain the evaluation or testing data. To find the interesting images from an evaluation perspective, we're going to filter away the training data. Here we see all the images which is not training data. So it's either testing or validation data. And if we zoom out, we can see that we have relatively diverse set of data in our testing set. Although most of the data is actually this kind of highway outside scene. But we have some images taken inside with fisheye camera. And we can see that sometimes the car gets detected. But especially when the car is close to the camera, it is not detected. And we also have some false positives here close to the privacy mask, I suspect. So we can already here get kind of a feeling for what kind of data the detector is good at and what kind of data it's not good at. We can see the same kind of behavior here on the inside scene, that when the camera is too close to the car, in most cases it doesn't detect the car. This is just a ground truth box. So to improve this, we need to add more images, and I have uploaded quite a few images which are not yet annotated. So if we want to find all the images that is not yet annotated, I have a flag, a binary tensor for that. If we filter that, we find that we have 404 images which we have not yet annotated. So we can see that it is a few different situations. We have some outside images which looks kind of like the ones along the highway, which we had already quite good accuracy on. We have some other outside images here from a boatyard, which is quite different. So I suspect those can be quite interesting. And we have some fisheye images from a more city-like environment. So we could just, based on this quick analysis, say that we should annotate all the images from this scene and all the images from this fisheye views. And since this is quite small data set, it's quite easy to do this analysis. But if we had a massive data set, we would not be able to do this manually. So that is where Manot comes into play. What we will do now is to build a data flywheel, or rather all the components in a data flywheel that could then be automated using pipelines. A data flywheel is a process that uses data and becomes more and more efficient the more data you put into it at each iteration. And I will soon explain why this is the case with this data flywheel. But first let's dive into the details and look at the different components. So we started with our images and our annotations, which are stored in an Activeloop deep lake dataset. These images and annotations was used to train our original model using the TensorFlow Object Detection API. And then I used this model to make predictions on all the images in the dataset, so that we could store the image or the predictions of the images together with the images and annotations. And that is what we have now been looking at in the Deep Lake Activeloop UI. So this way is very efficient to understand what your data look like and how the model reacts to different kinds of data. But what we'll do now is to scale this up and make it efficient in larger data sets where we can't manually look at all data. And we will do this with a service called manot.ai. So the first step is that we will use the manot.ai setup API call. And we will give it access to our images, to our annotations, and to our predictions. And this data will be used by Manot to learn as a model about how our data and how our model is acting. So kind of the same insight that we would get from manually looking at all the data in the Activeloop user interface, but in a programmatic way. And this data is stored in some kind of model which we has an ID to. The next step is that we will have some kind of stream of incoming images. So it could be a bunch of network cameras installed in different sites that are sampling a few images every now and then and sending to our image dataset. And what we want to do is not annotate all the images, because annotation is very expensive and time consuming. And in many cases, a lot of the data will be highly correlated, or it might be skewed, so it doesn't generate much value to annotate some of the images. So instead we will run them through the manot.ai filter. And this filter will use the ID of the setup process that we ran first, and take the stream of or the data set of new images and subselect a few of them, for example 10% of the images that we want to use. We could also get a list of how interesting each specific image is, so that we can act on that in a more clever way. The images that we select, so approximately 10% of the incoming images, they are then sent to Annotation and added to our image dataset and our annotations. So this creates the loop. So the next time we can rerun the setup process when we have more data and more information in our dataset, and also when we have retrained a new model and got new predictions. Then we will run the second iteration of this. So it kind of looks like an 8 here, that we start with some images, some annotations, we do training, we get a model, we use the model to get predictions, we use all of these free information sets to create a new manot insight model, and that model is then used to filter our new data, which is annotated and reinserted into the datasets. So this is what we're going to create. So what we're going to do now is actually that we're going to use the manot tool to evaluate how interesting these different images are. So we can read a bit about manot on their GitHub page. They have some information about how we can use it, and there is also an API documentation. But the interesting thing is that just yesterday they released an integration with Deep Lake, so that we can get images directly from Deep Lake and get the insight result from manot. So basically there are two different steps. We first have a setup process where they go through all the predictions and ground truth on all our annotated images to decide what kind of situations we are performing good at and what kind of situations we're performing badly at. And then we have the second step, which is the insight step, where we can apply it to not yet annotated images and get a score about how interesting is this particular image from a training point of view, which means that then we can filter on images with high score and send those images to Annotation. So I'm going to do this with IPython. First, I make sure that I have Deep Lake imported, and I'm also going to import the manot client library. I'm going to load my datasets. And check out the branch that I just showed you in the user interface. So this branch corresponds to the branch that we currently have open here. So what we're going to do now is that we're going to branch out a new branch from this one, which we use to store the insight results. So in this new branch, I'm going to create 2 new tensors. So we can see the tensors that we already have. We're going to have one tensor which specifies if we have insight information on the sample. I will have one tensor that specifies the score or how interesting the sample is. So to start with, I'm going to fill this with a default value. None of the images has any insight information yet, so we set all those values to false. And then we just fill the score, which will be a floating point number, with zeros since we don't have any better value. And we have the Boolean flag that tells that this is not valid yet. And we commit this change. So the next thing we're going to do now is to run the setup process for manot. And for that we need all our images which are annotated and which has evaluation results. I'm going to use the query engine in Deep Lake to do this. And I'm selecting everything where it's annotated and predicts. And we have a prediction result. We can now see how many images the setup will be performed on. So we have 537 images. Next thing is that we need to save this view because we need to have a view ID for the Manot API. So I'm going to specify an ID for this view. So this will be a persistent view that can't be changed. So the next thing we're going to need is some tokens for Manot and for Deep Lake. So I have already saved these tokens to a JSON file, so I'm just going to read them like this. And then we're going to create the Manot client using our Manot token. Then we're going to run the setup call. We're going to specify provider is Deep Lake. It will find our data there. We give it a name of the setup. We specify the format of the bounding boxes. We specify our Deep Lake token, our Deep Lake data set, and here we need to have the ID of the view. To make sure that it is only using the annotated and predicted images. And we need to specify the keys where it can find the prediction bounding boxes, labels, and scores, and also the ground truth bounding boxes. And ground truth labels key. Let's see, this should be labels. Sorry, it was. And all the classes, which is just cars in our case. Now let's run the setup process. And what happens now is that the algorithms in Manot will connect to our deep lake datasets, go through all the images, and learn some kind of distribution about how the images looks like and how our predictions are acting, what cases they are performing good and performing badly. So we can use this setup multiple times if we want to, but if we retrain our detector or add a lot of new images to our datasets, then it makes sense to rerun the setup process to learn the new properties of the new models that we have. Yes. So now when the insight process is finished, that means that we have a statistical model based on our dataset and our machine learning model, which can be used to predict how interesting the new images are. So the next thing we're going to do is that we're going to select the images that is not yet annotated and ask the Manot service, which of these images do you think we should annotate? So we're going to do that by creating a new view of our data set. We select everything that is not yet annotated. We see that we have 405 different images. And now we're going to call the insight process. We're going to give this insight a name. We're going to use the setup ID, which we got from this setup call. So it points out which statistical model will we base it on. And we're going to, first, before we do this, we need to actually have an insight ID or the view ID. Let's do like this and it will fail. And we call insight view.save view. Just do like this. So we will save a persistent snapshot of this view of the not yet annotated images. We paste the ID of the view, and then again we can run this. And so we tell it to run on all the data sets in this view, which only contains the images that are not yet annotated. So this will go through all the not yet annotated images and analyze how interesting they are from a data point of view. So we know what to annotate. So now the insight process is done. We can look in our data here and see what images it proposed for us. If we look at the ID, we have an insight ID of 183, and now we can actually find that in our Activeloop account, this should have created a new data set, which is called insight. Let's see, so perhaps we should have data set. The dataset ID is 223, and that is what we find here, that we have a dataset with that ID. And here we can find the images that the Manot tool proposes that we should annotate. So we can see that this is a subset of the images. And if we go back to the IPython terminal, we can run the get score command, and this will generate a list of scores. Here, for example, we can see that the 404th image in our data set, or rather in our view, has a score of 2.66. So that this is in a 0 to 10 scale. So if we want to get this data back to the original data set, then we need to do a bit of mapping here. So first off, we need to get our image ID from this. So we need to parse this integer. So we're going to need this function later. This function just does a regular expression to find the ID as an integer. Run this now and then look at the first. And now we can see that we have converted it to an integer ID. But this is the ID in the view, which is a sub-selected view from our data set. So to find the ID in the original data set, we can use the data set IDs. If we take on our data set, and each image's tensor will have a unique ID, which you can access in this way, and we get them as a list. And then we can use this function that we had up here, which will get the ID in the view and index our immutable view, take the ID of the image and find which index in the original data set this unique index is found at. If we make a new mapping here, we will get the IDs in our initial or original data set, which we now can see it is still IDs, but it's in the big data set containing all the images. And this means that we can now create a for loop which will go through all the scores. If we do like this, we will iterate all the different scores that we got from manot, and we will update our data set with the score in the insight score tensor, and we will also set the insight done tensor to true to indicate that the image has been evaluated by a manot. And now when we have updated these tensors, we can look at the difference and we can commit this. Now we can go back to our original data set that we were working with. And we select the branch. I don't remember what it was. So we're checking out the branch with the insight metrics on. And what we can do now is to filter on images which are which has insight. And even more, what we can do is that we can order by insight score in a descending manner, which means that in the very top should have the images which are most interesting from an annotation perspective. So we can, for example, see that here we have some images which contains only a tiny fraction of a car. Here we have an image where we can see the front part of a car, and we can see that our detector actually is incorrect on this one. Here we have one of those fisheye images with a car that doesn't get detected. Here we have an image with a car that doesn't get detected. Here we have an image with false positives, something down here in the corner, and here we have another part of a camera that is together with actually this front of a car is detected as a car. So this is the basic idea of how we can use the manot tool to automatically find images which is interesting for annotation. And in this case, we had quite little data, so it would be possible to look through the data manually and decide which images to annotate. But the bigger the data set gets, the harder it is to do that. And the whole idea with this is that we can automate the things. Instead of doing the steps manual as we did now, we can automate the full process. So the camera will automatically upload images to our data set, and that will automatically every now and then trigger a manot insight process, which will select a tiny subsample of images which are very interesting from an annotation perspective, so that we can automatically send that to the annotation queue and let our annotators annotate the images and then retrain the detector on it. So the idea is that we should get much better results much faster than if we spent a lot of time annotating every single frame that we don't actually need. So that's all for this video. Thank you for looking, and you can subscribe to YouTube channel and my LinkedIn profile if you want to see more videos like this, more insights about Manot, more insights about Activeloop and machine learning operations. So thank you for looking.